In the rapidly evolving world of AI models, NVIDIA's latest release, the Neutron Ultra, is causing quite a stir. But here's the million-dollar question: can it really outperform models with trillions of parameters and yet still be more efficient? Well, buckle up, because this 253 billion parameter beast is doing just that. Smaller, smarter, and more resource efficient than its larger counterparts, Neutron Ultra is shaking up the landscape of AI with its powerful features and exceptional performance. So what's all the hype about? The introduction of Neutron Ultra, a breakthrough in AI efficiency. Neutron Ultra represents a major leap in artificial intelligence, achieving a level of performance that's previously been unattainable with fewer parameters. While DeepSeek R1 flaunts 671 billion parameters, Neutron Ultra, with its 253 billion parameters, is showing the world that size doesn't always equate to power. Built on the foundations of Meta's Llama 3.1405B instruct model, which itself was known for robust instruction-following capabilities, NVIDIA refined the architecture using a technique known as neural architecture search. This cutting-edge method allowed NVIDIA to tweak the model's architecture, eliminating unnecessary components and optimizing the remaining elements for maximum efficiency. What's more, Neutron Ultra can run on just a single setup of 8 H100 GPUs, showcasing its resource efficiency. For comparison, many larger models require extensive setups of multiple GPUs, which can be prohibitively expensive and complex to maintain. Neural architecture search, a new approach to AI model design. The secret sauce behind Neutron Ultra's breakthrough performance lies in neural architecture search, a technique that automates the process of designing the neural network structure. Neural architecture search intelligently selects which parts of an existing model's architecture to keep, discard, or modify to achieve optimal performance. For Neutron Ultra, neural architecture search enabled the team at NVIDIA to keep the most powerful elements of Llama's architecture while eliminating the inefficiencies. This resulted in a model that's not only smaller, but also faster and less resource-hungry. One of the standout features of neural architecture search is its ability to streamline memory usage. For instance, certain blocks in the network completely skip the attention mechanism, while others fuse multiple feed-forward networks into more efficient systems. This clever design reduces memory consumption significantly, allowing Neutron Ultra to pack a powerful punch while operating on fewer GPUs. These advancements mark a turning point for AI, where larger doesn't necessarily mean better, but rather more efficient. Switchable reasoning, tailoring AI to your needs. NVIDIA's Neutron Ultra also introduces a unique switchable reasoning feature, which allows users to toggle between two modes, reasoning on and reasoning off. This gives developers a new level of control when interacting with the model. For simpler tasks like generating short answers or instructions, reasoning off provides faster results. But when faced with complex challenges like math problems, code generation, or advanced Q&A, turning reasoning on gives Neutron Ultra access to its deeper, more sophisticated reasoning capabilities. In the real world, this feature is a game changer. Imagine a developer working on an AI assistant. They can choose whether the model responds with a quick answer or dives deep into the problem for a more detailed response, depending on the situation. And it works. The model has been tested with a variety of benchmarks, and the results speak for themselves. For example, in the Math 500 benchmark, reasoning off delivered an accuracy of 80.4%, but with reasoning on, the accuracy jumped to 97%, a staggering 16.6% increase. It's clear that this toggle isn't just a neat feature, it's a tool that can significantly boost the model's performance. Neutron Ultra's performance on key benchmarks, surpassing expectations. When compared to its larger counterparts, Neutron Ultra holds its ground and even outperforms them in some key tasks. For example, the model's performance on general question answering tasks was a huge success. In a side-by-side comparison with DeepSeek R1, Neutron Ultra scored an impressive 76% in reasoning on mode, while DeepSeek could only manage around 60%. This is particularly impressive when considering that DeepSeek R1 is a model built with a whopping 671 billion parameters, which makes Neutron Ultra's success even more remarkable. However, the model isn't flawless. On more challenging math-related benchmarks like AIM 25, Neutron Ultra did lag behind DeepSeek R1, achieving 72.5% accuracy compared to DeepSeek's 79.8%. While the difference isn't monumental, it still illustrates that for certain tasks, Neutron Ultra isn't quite at the top of the leaderboard. However, it's important to remember that Neutron Ultra offers this level of performance with significantly fewer parameters, which makes it a compelling option for developers looking for a more cost-effective, efficient solution. Why is Neutron Ultra so efficient? The key to Neutron Ultra's remarkable efficiency lies in its innovative design. Unlike other models that require massive memory resources to function, Neutron Ultra's architecture ensures that the model runs efficiently even with fewer parameters. This is made possible through the use of memory optimization techniques like skipping certain attention mechanisms and compressing feed-forward networks. Furthermore, Neutron Ultra benefits from vertical compression, which means that despite having 253 billion parameters, it doesn't consume as much memory as other models with similar size. As a result, Neutron Ultra can run on just 8 H100 GPUs or even on systems with NVIDIA's B00 or Hopper architectures with BF16 or FP8 precision. This makes it much more economical for large-scale inference tasks. What's even more impressive is that NVIDIA has managed to pull all this off without sacrificing performance, proving that power and efficiency can coexist in a single AI model. A thorough post-training process for better performance. NVIDIA's approach to Neutron Ultra's training is nothing short of comprehensive. The company didn't just stop at optimizing the architecture. They ran a multi-phase post-training pipeline that took the model through several rounds of supervised fine-tuning. This fine-tuning focused on tasks like math, code generation, chat, and tool use, ensuring that the model could handle a wide variety of real-world applications. After fine-tuning, the model underwent a round of reinforcement learning using group relative policy optimization to further refine its instruction-following capabilities. On top of that, knowledge distillation was used to make the model even smarter by feeding it with 65 billion tokens. Following this, additional pre-training was conducted using 88 billion tokens. The synthetic data used during training was also particularly important, as it allowed the model to learn how to handle real-world tasks that required toggling between reasoning on and off. These multiple layers of training and refinement make Neutron Ultra one of the most robust models available today. Handling long inputs. Neutron Ultra's secret weapon. One of the standout features of Neutron Ultra is its ability to handle incredibly long inputs. With a maximum sequence length of up to 128,000 tokens, Neutron Ultra is a true powerhouse when it comes to processing large amounts of data. For context, most AI models struggle with longer sequences, typically capping out at 4,000 to 8,000 tokens. Neutron Ultra, however, can handle far more, which opens up new possibilities for applications that require processing lengthy documents or extended conversations. For instance, a chatbot built with Neutron Ultra could remember long exchanges with users, making it much more effective at providing relevant responses over time. Similarly, for developers working with large code repositories, Neutron Ultra can analyze and summarize entire sections of code, making debugging and code generation a breeze. This capability to process long sequences with ease is a real game changer for developers working in complex fields like legal tech, scientific research, and software development. How to integrate Neutron Ultra. Easy setup for developers. Integrating Neutron Ultra into your project is simple and straightforward, especially if you're already familiar with the Hugging Face Transformers library. NVIDIA provides clear instructions for setting up the model with Python, which makes it easy for developers to get started. The model's reasoning on /off modes are controlled by a simple system prompt, allowing developers to toggle between deep reasoning and quicker, more deterministic outputs. For the best results, NVIDIA recommends setting the temperature to 0.6 and using top_P of 0.95 for reasoning on mode, which introduces some creativity. On the other hand, for reasoning off mode, you can use greedy decoding or set the temperature to 0 to make the outputs more predictable. The process is designed to be as simple as possible, with all the necessary code and setup instructions provided in NVIDIA's examples. This makes it easy for developers to integrate Neutron Ultra into their projects, whether they're building AI assistants, chatbots, or other advanced tools. Licensing. Open source and ready for commercial use. NVIDIA has made it clear that Neutron Ultra is not just another closed-source project, it's open-source and ready for commercial use. The model is released under the NVIDIA Open Model License and the Llama 3.1 Community License, which allows developers to use it in their projects, even for commercial applications. The open-source nature of Neutron Ultra is a big deal, as it provides developers with the flexibility to customize the model to suit their needs. However, NVIDIA does emphasize the importance of testing for safety, bias, and ethical concerns. They've even set up a platform where users can report potential vulnerabilities or issues with the model. This transparent approach ensures that the model is used responsibly and ethically, which is vital when dealing with powerful AI models. By making the model open source, NVIDIA is not only giving developers access to cutting-edge technology, but also encouraging responsible innovation in the AI space. What's next for Neutron Ultra and the Neutron family? Neutron Ultra is part of the larger Llama Neutron family, which includes other models like the Neutron Nano 8BeV1 and the larger Neutron Super 49BeV1. The different models in the Neutron family offer a range of options depending on the use case. Neutron Ultra, as the sweet spot between raw power and efficiency, is likely to be the go-to choice for developers looking for a powerful but efficient solution. The other models in the family offer even more flexibility, so developers can choose the right model based on their specific needs. NVIDIA's commitment to continuing the development of the Neutron family suggests that we can expect even more advanced models in the future, further pushing the boundaries of what's possible with AI. And that's a wrap on today's deep dive into Neutron Ultra. It's clear that NVIDIA has once again set the bar for AI models, proving that bigger isn't always better and efficiency can pack a serious punch.